When we're dealing with combustion reactions, we're usually looking at a reaction, oxidation reaction with atmospheric or ambient air. And so for these, we're looking at a reaction between a fuel and air. So when we say fuel, it's usually a hydrocarbon fuel. And in doing this, what we're going to do, we're going to make an approximation for the composition of air. And we'll approximate it as being 21% oxygen and 79% nitrogen. In reality, there are other gases in air, atmospheric air, but that's what we'll use when we do the analysis for combustion. And so with that, the molar mass for air that we consider for combustion reactions would be 21% for oxygen, and then its molar mass, 16 multiplied by 2 because it's diatomic. And then molar mass for nitrogen, 14 kilograms per kilomole, 2 because it's diatomic, and what we end up with is 28.84 kilograms per kilomole. So that's what we'll be using for the molar mass for air. And for each kilomole of oxygen, because remember, we're saying that it's an oxidation reaction, so oxygen is combining with the hydrocarbon fuel. So for 1 kilomole of oxygen, we have 3.76 kilomoles of nitrogen for a total of 4.76 kilomoles of air. So that's the balance that we have that we'll be dealing with. Now, when we look at the nitrogen that comes through, the nitrogen usually does not react. Ideally, it will not react. Sometimes it does, and that leads to problems, as we'll see in a moment. So what we see here is that nitrogen is typically along for the ride, and so it's not really reacting. It's what we would call an inert gas, but sometimes in the reaction zone, if the temperature gets too high, what happens is the diatomic nitrogen can dissociate into 2 single monatomic nitrogens, and then those look for other bonds, and quite often oxygen is available, and so then we get the formation of nitrous oxide and NO2, or NOx, as are commonly referred to when we talk about pollution. And NOx are bad because what can happen is they can undergo conversion with ultraviolet radiation from the sun, resulting in what we would call photochemical smog, which causes kind of the brown cloud that you'll sometimes see over a city. And they can also react and create acid rain when they would be absorbed by water, and leading to an acidic rain. So those are 2 of the disadvantages that we can have with nitrogen if the temperature gets too high. What I want to do now is take a look at a story that just appeared recently being in 2013 in Hong Kong. And I was there recently, and in the newspaper there was an article in the International New York Times, and the title of it was "Green Solution Proves Troublesome for Hong Kong." And what they were referring to is that over the last decade, they've shifted over 18,000 taxis. There are over 18,000 taxi cabs in Hong Kong, and several thousand of their minibuses, which hold, I think it's around 16 people. They've converted them all to liquefied petroleum gas, and this has taken place over the last decade. And it's been a very expensive conversion process, approximately $5,000 per vehicle. So let's take a look at a little bit of a video clip of what transportation looks like in Hong Kong. So there we can see the waterfront of Hong Kong, and I believe that's the Walk of Stars. But there you can see the taxi cabs. They're also double-decker buses. The double-decker buses still use diesel, but the taxi cabs have all been converted to LPG. There's one of those little vans, 16 seats. It holds 16 people in it. That has also been converted to LPG. And there you can see a typical taxi cab. I zoom in and you're able to see the little symbol on the side. It's LPG. And all of the vehicles now made by Toyota, they're LPG Comfort. And there you can see the tank in the back of the trunk. And there's a little fuel gauge there, enables the driver, and then you can see where you can put the fuel in, LPG. When you look at the engine really isn't all that significantly different from a typical fuel burning car that would have liquefied fuel such as gasoline or diesel. But those are the vehicles that they have in Hong Kong, and so they've gone through a very extensive effort at greening the city, and that's a great effort for Hong Kong, and it's very nice that they've been able to do that. However, despite doing that over the last decade, they've noticed since 2008 to 2012, there's been a 20% increase in the amount of nitrous oxide in the atmosphere, and that causes things like this. So you can see there in a video image, there's some smog in the distance, and that's not a good thing. And so the scientists started to wonder, well, what's going on? We've converted to LPG. That should be a nice greener fuel. It burns cleaner. Why are we getting more nitrous oxides in the atmosphere? And so they have done a study, and what they found is these taxi cabs, remember, run almost non-stop, almost 24 hours a day, as well as the little mini buses. They're running almost 24 hours a day. But what they found is that the catalytic converters in these vehicles is starting to get clogged or fouled. The catalytic converter completes the oxidation reaction for unburnt hydrocarbons as well as nitrous oxide in the exhaust gas. And what they found is that they're getting fouled, and so they need to replace them. And what they found is that the fouling takes place over about an 18-month period. And so now the taxi cab drivers will have to replace their catalytic converters every 18 months. And they will pay for the first version of that, which is about $1,300 per vehicle. But after that, the taxi cab drivers themselves will have to pay. So let's take a quick look at what the catalytic converter is. And here we have a picture of a BMW. It's a V8. There are two catalytic converters shown in green. And then this is a picture of a Chevy V8. And you can see there's an oxygen sensor and the catalytic converter. It's basically something that is in the exhaust system of the engine. And what the catalytic converters do is they complete the reactions coming out of your engine. And so they're put within your exhaust system. So what the catalytic converters are doing is they're completing the reaction for the exhaust gas coming out of your internal combustion engine, and they will complete the combustion process or oxidation for the unburned hydrocarbons as well. They will help remove nitrous oxide, and what they're doing is they're taking carbon monoxide and oxidizing that. There will be a catalyst in the catalytic converter that enables this reaction to take place at a lower temperature. The hydrocarbons themselves will then react fully all the way to water vapor, and finally the nitrous oxides will then react all the way back to diatomic oxygen and diatomic nitrogen. So that's what the catalytic converter is doing. Unfortunately, what they're finding in Hong Kong, even though they have a greening solution, it's leading to a fouling of the catalytic converter, forcing it to be replaced. So it'll be interesting to see in the future how we as engineers respond to this challenge, whether or not we change catalytic converters, because that's a little pricey to have to go and change the catalytic converter as often as what they would find in Hong Kong. But that completes this segment looking at how we treat and handle air for our reaction equations.